chapter. This chapter is taken from the book Embedded System Design, a Unified Hardware Software Introduction, and it is the chapter 4 of this particular book. All these information is available on the Google Drive. I have already uploaded a lecture on YouTube, namely lecture 26. You can also view this lecture on YouTube. In addition, I will also upload today's lecture. So in standard single processor, we will study different peripherals, which is type of peripherals. So what is a single purpose processor? What is a single purpose processor? What's the job of a processor? जी बताएं बेटा. What's the job of a processor? Single purpose processor.
तो यूनिट टास्क करोगे ना, मतलब कि एक टास्क करेगा एट अ टाइम.
Right. What is the difference between a single purpose processor and a general purpose processor? जी बेटा. What is the difference between a single purpose processor and a processor? So now we would like यहाँ पे what is the difference between a single purpose processor and a general purpose processor? जी बताएं बेटा. What is the difference? Single purpose processor. जी बताएं बेटा. Now we will say that okay, a general purpose processor perform general task. What are different phases of execution? What are different? What are phases of a processor? What are different phases of execution of a processor? In execution of instruction. I have taught in the previous lecture. जी बताएं. What are different phases of execution? Anybody? Actually, what is the job of a processor? बताएं बेटा. What's the job of processor?
सर टेकिंग अ डिसीजन, मतलब एग्जीक्यूशन वगैरह जब हो रही होती है तो.
Very good. Understand? Yes, it takes a decision, but it performs a processor. Theta. What are these theta? जी बेटा. Data transfer. And
यस सर.
data transformation. And what is the other job? Control. If you remember.
फॉर इंस्ट्रक्शंस.
Okay. So in the data transfer instruction, we processor transferred the data between two registers, or from register to memory, or from memory to register, or from memory location to another memory location. In a data transformation, so what is the classical example of a data transformation? What is a data transformation? It performs operation on the data.
Add, mul.
Add, subtract, mul. So actually, if we classify the instruction, we can classify the instruction and also and what are in the flow of the program. If you remember, if changes the flow.
Jump wali jo.
Very good, very good. So jump, very good. JSR, jump to subroutine. Okay, return from subroutine. So these are different examples of a control instruction. So this is the Java processor. Processor perform three tasks, and actually it is the brain of embedded system. So we can say of embedded, which was the information. Where the it processes the information. Where the information is stored. Where is the information stored? जी बताएं बेटा.
Memory.
Where is the information? Yes, very good. The information is stored in memory and also some small register in the microprocessor.
Register.
Information is stored in memory and register. So it extracts the data. It extracts the data or extract the data from the memory and the register. How does this state of state of a microprocessor? How do you define the state of a processor? The state is defined by the what? By content of what? Content of
registers,
and memory at
memory.
any particular particular instance or time. Asha, at any particular instance or time. What is an instance? What is an instance in a processor? What is an instance in a processor? Do that. If you say that any register has any particular value, maybe a register R0 is storing a value of 65. So at any instant, and if we write to that register, so then this register content will be modified and next instant. How do we define an instance of a microprocessor? Or time interval? How do we define a time interval? A different time units or different times. Let's assume if you wake up in the morning, so we have different instants in a day. Now it's a morning time, it's noon time, and then you have an afternoon time, and then you have evening time, then you have night time. Like these are different instances of the same day. So how time is determined in microprocessor? जी बताएं बेटा. Clock or not?
Yes,
Yes. So the instance in the microprocessor is defined. So the instance clock. And actually, when we define the clock, so we have a clock frequency. So now, if we say the instance is defined, we can say now we have a clock. So we have a clock. Okay, if we say a clock, so the clock has some interval or not? Am I right or not? So clock has some frequency. Hmm? So if we say
yes.
we have a clock has some frequency, and this frequency determines the time interval, the time interval of a clock period. What is the clock period? जी बताएं बेटा. What is the clock period? So now this is a clock period. This interval is called as clock period. Can you see on the screen the clock period?
Yes, sir.
Okay. So now this is the clock period. If you look at the clock, so it has a rise time. So now if you think, so it's a rise time. So this is the rise time. And the clock is one for some interval. So this is the one. Now we have then a fall time. Can you see the fall time? And for some other duration, logical. How the so how we can determine the clock period? G clock period inverse of frequency. Am I right or not? 1 divided by f. Hmm? Let's assume. Let us assume clock frequency is 10 megahertz. So what is the clock period? What is the
So
clock
1
period?
over 10 megahertz divide.
1 divided by 10 megahertz. So actually we can write this 1 divided by 10 multiply by 1 divided by 10 to the power 6 plus 10 to the power 6 for mega. 1 divided by 10 is equal to zero point 0.1. Hmm?
0.1 micro आ जाएगा.
And 10 to the power minus 6. So it will be equal to 0.1 what?
Micro.
Micro. What is the unit interval? What is the unit?
Second.
Microsecond. So it means that this time interval. So this time interval is for this example. In this particular example, this time interval is 1.1 microsecond. If we have a clock frequency, of what?
10 megahertz.
10 megahertz. Okay, now we have defined what's a microprocessor, what's the job of a microprocessor. Okay, now the question is that if you look at the microprocessor, so here the instructions are stored. Where the instructions are stored? Where the instructions are stored? Where the instructions are stored? Where the instructions stored? We studied this in our instruction encoding class. Where are the instructions stored? Beta.
Mem
Memory and register.
Register.
Memory. No, memory. The instructions are stored. The instructions are stored to memory. So what are the different phases of the execution of instruction? Different phases of execution of instruction. So we can fetch the instruction fetch stage, followed by instruction decode stage, then operand fetch stage, then instruction, then operand store stage, and then next instruction. So this cycle. So what happens in instruction fetch? Because the instruction are fetched, the instruction are stored in memory, so we need to fetch the instruction. So in the instruction fetch state, the instruction fetch state is fetched from memory and loaded into which register? जी बताए बेटा. Memory buffer register, if you remember.
Address register.
Then instruction decode state. And instruction decode state, we decode the instruction. That what instruction is loaded into, and it determines type of instruction it is. What type of instruction? Add instruction, for example, whether it is add instruction. There can be various classes of instruction. So the instruction decode stage, we identify the type of the instructions. Once the instruction type is identified, then we have the operand fetch stage. The instruction may also require some operand. Let's assume if the instruction is add R3, R4, R5, we need to fetch two operand. We need to fetch two operand R4 and R5. So we need fetch source operand or destination operand.
Source.
Source operand. So where the source operand are stored? Where can we where are the source operand stored? Where are the source operand stored? Hmm? Where are the source operand stored?
Register.
Are stored, can be stored in register or memory. It can also be
Memory.
stored in memory. Or it can be part of instruction.
Immediate.
Part of instructions. It means it can also be an immediate instruction. Fetch the operands. So in the in the operand fetch state, we need to fetch the real source operand, and we need to pass this source operand, which need to be passed to the execution unit. Am I right or not? And the execution unit mainly contains of ALU. What does ALU stand for?
Arithmetic logic.
Arithmetic logic.
Logic unit. Okay, not logic unit. Okay, now when it's found, then which is the next phase of instruction execution? Operand execute. When the instruction executes, the instruction is executed. Whose operand is determined? The whose operand, uh, which is determined by which field of the instruction? Which field of the instruction? जी बताए बेटा. Output field of the instruction. And we have already studied this in the instruction set encoding. So the instruction is executed. Okay, when instruction is executed, so maybe there is some result of operation. So then we need to have another phase, and what is and in this operation, where the where the result can be stored? Where can be the result stored? जी बताएं. In memory or
memory registered.
and how do you determine? How do you determine the location of the operand? How do you determine the location of the operand? How do you determine the location of the operand? By what? टॉपिक पढ़ा है एड्रेसिंग मोड पे हो सकता है या नहीं बाय एड्रेसिंग मोड location.
Yes, sir.
Okay, so now there are different phases of the instruction. Now if you look at the topic, so now we if you okay, all of these examples, that we have not studied. Okay, well, so this phases or this architecture of a processor, general purpose processor or specific purpose processor, जी बताएं बेटा. It is a general purpose. A general purpose processor performs general tasks. What are the tasks performed by the processor? It can perform an add operation, it can perform a subtract operation, it can perform multiply or divide operation. So it's the architecture of a general purpose processor. Now, if we compare this processor with a single purpose processor, so the difference between a general purpose processor and a single purpose processor is that a single purpose processor performs a specific computation task. It only performs a single task, and it is designed for a unique task. It is designed for a unique task. Okay, and we also call it as off-the-shelf components. It is pre-designed for a common task. They are also called as peripherals. And in these peripherals, we will also study serial communication and log-to-digital conversion in our upcoming slide. So what's the difference between single-purpose processor and a general-purpose processor? जी बताइए बेटा.
सर सिंगल पर्पस में वो स्पेसिफिक मतलब के टास्क करेगा तो जनरल में वो जनरल
Yes.
पर्पस.
What are the examples of general-purpose processor? In general, what are the general-purpose
सर
tasks?
ऐड हो गया, मल हो गया, सब्ट्रैक्शन
Yes.
लाइक.
My general-purpose tasks are very simple, like add, subtract, logical instruction, shift instruction. Broadly, the instruction can be categorized into the arithmetic and logical operation instruction, and also the shift operation, and also the control operation, we can also categorize into data transfer instruction, data transformation instruction, and the control instruction. So these are different categories of the instruction. So this is the general purpose processor, and then it performs general purpose task. And a specific, like in a single purpose processor, they perform very specific tasks. And we will study different examples of we will study different examples of a single purpose processor. Ji beta. Okay, so what is a timer? What is a timer? Hmm?
सर काउंटिंग के लिए टाइम
बेटा I will come in 5 minutes. ठीक है, I want a 5-minute break. ठीक है बेटा?
ओके सर
ठीक है, I need a 5-minute break. I'm stopping this at this point and then I will start. ठीक है बेटा? Counter, timer. What is a timer? Hmm? What's a timer interval, and how does the timer works? So a timer is used to generate time output events. Okay, it can also used to generate a delay. It can be used to generate a delay. For instance, if you want to hold the traffic light green for 10 seconds and you want to hold the traffic light red for 1 second, so it can be used to generate the the delay between two different events. So now let's assume that you have a traffic light and it's now red and now it will become green. The time between the traffic light to turn from red to green, and it requires a delay. So this delay can be generated using timers. समझ आ गई बेटा या नहीं आई?
जी सर
Okay. Now, actually, if you look at the if we look at the details of a processor, so it consists of clocks. Okay, it consists of clocks. So it's a clock, and we measure the time in terms of the clock interval. So now this is a clock interval 1, this is clock interval 2, this is clock interval 3, and now this is clock interval 4. So now let's assume that the duration of this clock period is 1 microsecond. So now let's assume this duration is 1 microsecond. And now we have a counter. Okay, and we have a counter or some kind of a counter, or we have a timer. So now let's assume we have a timer or counter. Okay, and this counter is let's assume very small counter, 4 bits. How can it count? What's the minimum count and what's the maximum count? What's the minimum? What is the minimum count?
0
Hmm?
15
Very good. 15. So let's assume the count, if the count is n bit. Now let's assume the count is n bit. Count is 0 for both. And what's the maximum count for
n minus 1
n? No. 2 raised to power
2 raised power n minus 1
for n minus 1. So now this is the maximum count. So this maximum count for an n bit data. So now let's assume that the counter is counting the clock intervals. The clock interval. So now this is the starting point. This is the starting point. This is the starting point. So at this point the counter value is 0. Okay, at the rising edge. At the next rising edge, what will be the value of the counter? It is initialized to 0. So let's assume this is the count time of the counter is 0. And next clock edge, what will the value of counter? 1. And the next clock edge, the value of the counter will be 2. And the next clock edge, the value of the counter will be 3. And at next clock edge, the value of the counter will be 4. So the counter can be used to count the clock cycles. So the one type of counter is the counter can be used to keep track of cycle. And it can be used, counter can be used. Let's assume that our clock period is 1 microsecond. So now let's assume clock period is one. Since the clock period is 1 microsecond, what is the clock frequency? This implies that clock frequency is 1 megahertz. Am I right or not? From 1 megahertz, if you take the
Right,
inverse
sir.
of this 1 megahertz, let's assume the clock period is 1 microsecond, and the value of the counter, the value of is 9. Because if it's 9, so it's a 4-bit counter, so the value will be 1001. Am I right? Hmm? So what's the delay now? What is the delay? Counter. The delay of the counter is equal to count value multiplied clock. What's the count value in this particular example now? Now,
9.
it
1
1
microsecond.
second. So actually, the total delay now will be the total delay is 9 micro. How can we count the delay? So how we can how we can determine the delay? So now let's assume where the different applications. Where the different applications. So this timer encounter a different application. Traffic, right? Am I right or not?
Right,
आवाज आ
sir.
रही है बेटा?
Yes,
Traffic
sir.
light में. Or what are different other examples? ATM machine. Can you say why it should be used in ATM machine? Hmm? Let's assume you insert a card. The user inserts a card, hmm? And it does not press an input for 5 minutes.
Yes, sir. वो automatically वापस आ जाता है. Okay, sir.
Then it will give the card after some delay or some time. Am I right or not? So there are different examples of the ATM machine, and it can also be used to detect the speed of a car. Now let's assume now you cannot. You have a camera. Let's assume there is a camera on the motorway with the motorway police. Hmm? And now it's a car approaching. It's a car coming. Okay. So now what you can say, it will transmit a signal. Hmm? Transmit a signal, and maybe by that time the car is here. When the signal will hit the car, so it will then receive the signal. So then it can measure the delay when the signal was transmitted and the delay when you receive the signal. So you measure the delay. So how you can measure the delay? So you measure the delay between two time in events. Between two time between two events. Two events. What are the first event? What is the first event? Huh? Amita, what is the first event? Embra transmits the signal. What is the second event?
Receive, sir.
The camera receive the signal. And if it can, okay, so now if we transmit the signal and receive the signal, so there will be some algorithm, and then they say, okay, so now it means that now the car has traveled a distance of this time period. So now this is the travel distance, and using the distance and using the, the time interval, you can determine the speed of the car. So another application is also to determine the speed of a car. Okay, so now it's also how we measure the delay. How do we measure the delay? So at the first event, what should we do? What should we do? We should reset the counter. Am I right or not? And when you receive the signal, what should you do now? Reset the counter. So the counter value will now be, what will be the value of counter? Counter value will now be 0. Am I right or not?
Right, sir.
And if you receive the signal, so what should we do at that point when you receive the signal? What should we do now? We have reset the counter. Reset the counter. Counter value will be 0, and then also start the counter.
और वो फिर काउंटिंग स्टार्ट कर देगा ना.
Yes, and start the counter. And it's when you receive the signal. What should we do now? When you receive the signal,
फिर अगेन एक वैल्यू आ जाएगी उसकी
Counter.
कौन
so we should read the value of the counter. Am I right or not?
राइट सर.
Read the value of the counter. When you read the value of the counter, so what does the counter value? So the value of the counter will give you some information. What is that? What is that information? That information is info. The information delay. How you determine the delay? ये बताएं. How you determine the delay?
Counter multiply by clock period.
Counter value multiplied by
Clock
clock
period.
period. You understand this point or not? Okay. So it can also use to measure the clock speed, and based on the counting clock pulses. So let the clock period be 10 nanosecond, and we count 20,000 clock pulses. So then 20 microsecond will be passed. So it means that now you have in this scenario. So now in this example is given. So let's assume that the clock period is 10 nanosecond, and we count 20 clock pulses, 20,000 clock pulses. So what is the delay? You बताइए बेटा. 20,000 multiply by 10 nanosecond.
यस सर.
ये कितने हो गए ये? I write it like this: 200 multiplied by 1000 nanosecond. 1000 nanosecond is equal to microsecond or not? 1000 nanosecond is equal to 1 microsecond. So this is equal to 200. Am I right or not? So then 200 microsecond has passed. So now is the calculation behind this. The delay will be equal to the count value multiplied by the clock period. If you this, so this will be equal to 200 multiplied by 1000 nanosecond, and 1000 nanosecond is equal to 1 microsecond. So it will give you a delay of 200 microsecond pass. So now let's assume you have a 16-bit counter. So what is the maximum resolution of a counter? What is the maximum resolution of a counter? So now let's assume we have a 16-bit counter. So now let's assume we have a 16-bit counter. So what is the maximum value of 16-bit counter? Maximum value of 16-bit counter. So the maximum value of the 16-bit counter is equal to 2 raised to power 16 minus 1, and this is one is equal to 65,535. Am I right or not? Okay. So what's the maximum delay you can model? So what is the maximum delay you can model? So what is the maximum delay, if you can say, delay you can model with a 16-bit counter? The maximum delay that you can model with a 16-bit counter is 65,000 with a 16-bit counter, assuming a clock period of n nanosecond is 65,535 multiplied by 10 nanosecond. If you convert this into microsecond, so this will be equal to 6. Okay, now I have a question. So now let's assume. So what is the maximum delay? Maximum you can model then n-bit counter, assuming clock period, assuming a clock frequency. Okay. जी बताए बेटा. What is the maximum delay? Any question? Any answer? बेटा आप लोग सारे खामोश हैं.
97.5 microfarad.
With an n-bit counter. N-bit, you have now n n-bit counter. And the clock frequency is f. What is the maximum delay?
Sir, 2 की power n minus 1 multiply
Very good.
1 over f.
Very good. 2 raised to power n minus 1. It is the maximum multiplied by 1 divided by f, and f is the frequency, operating frequency. So this is the maximum delay that you can model with an n-bit counter. Okay? Acha. Now there is also a signal top. Top indicates when the top count reached, wrap around. So when the top count reach and it's a wrap around, so it means that now it is again reset. It's again reset. So now let's assume that what does it mean? That now let's assume we have a 4-bit counter. So let's assume you have a 4-bit counter. Let us assume so it will count from 0000, then it will count 0001. So what is the value of top signal? Top will be 0. Am I right? 0, and it will go on. Then it will go on. Then it will be a 1 0 1 1 0 0. And when the count reaches control C, is 1 1 0 1 0, then 1 1 1 1. It means that the value of the count will then become 1. Top means that now the counter has reached its maximum value. So the top indicates the counter reaches maximum value. And when it's incremented, what will be the next value? Again, and it's wrap around, right? Around the next value will be
Again
0
0
0
0 से start
0 0. And then what will the value of top? 0. Now the top is also reset. It means that now it will go to the second time interval. Okay? Now, if you look at the second, did you see the timer? Did you see a stopwatch? In a stopwatch, you have one for the second. So now it starts from 00 for the second, the indicator for the second, and it counts until 59. When 59 seconds is in elapsed, what's the next value of the second? बताएं बेटा. Now you have a minute indicator. Now let's assume minute is 00.
मिनट में वो एक ऐड हो जाएगा.
Yes. So the minute will be 01 and the second will again be reset to 00. So in this case, the top will reach, for instance, the top, if it's an event, so the top will reach 1 and down it will be equal to, because it has reached its maximum G. Now we go to the next slide. So what is a counter? What is a counter? The counter, like a timer, counter is also like a timer, but it counts pulses on a general input signal rather than a clock. Okay? So it can count the cars passing over a sensor. Okay? And we can also configure the counter as a timer, or you can also configure the device as a counter. Now I will explain this with an example. So now let's assume we can determine different events. Okay. So now if you look at the timer, now this is a clock. This is a clock. Okay. This is a clock. So what will be the value of timer? So the value of the timer will be 0 here, the value of the timer will be 1 here, the value of the timer will be 2 here, because the decision is taking at the rising edge of the clock. The value of the timer will be 3 here, the value of the timer will be 4 here, the value of the timer will be 5 here, and the value of the timer will be 6 here. So the timer, if you look at the timer, so what's the timer? So timer tracks clock pulses. It tracks clock pulses. Okay. Now instead of a timer, we have another structure that is a counter. Okay. So the counter, what does a counter? Counter tracks. What are these? So now let's assume that we want to have some events. And that event is some person walking through our way. So now let's assume it means that there is no events here, and now at this time you have an event, and then now you have an event. So this pulse so let's assume that we have the counter tracks event. So now this is an event. And this is also another event. Okay. So now what will be the value of a counter? What's the value of a counter here? Value will be 0 here. And when it will be 1? At this point it will be 1. And when it will be 2? At this point. What can be an event? How you define an event? How you define an event? Maybe any occurrence, maybe an occurrence activity. Now let's assume in IST you have a door. Now let's assume you have a door, and this is a door, and you want to consider how many people passes through this door. So actually, when a person strikes through this door, so it is an event. So when a person passes through, an event will be created. When another person passes this door, first person passes through this door, an event is created like this. When a second person passes through this, so it will also create an event. अब बेटा समझ आ गई या नहीं आई समझ? आवाज आ रही है या नहीं आ
Yes,
रही?
sir.
Yes.
Okay. So count. It can also be used to count car passing over a sensor. So now let's assume that you have a road, and a road there is a sensor there, and sensor detected a car is passing by or a car is not passing by. So whenever the car passes by, a sensor will detect it. It means that how many cars have passed this through a sensor. Gee, count cars passing through car. What is the application? What is the application of this scenario? Let's assume we say that cars are passing through. What is the application? We want to count cars passing over a sensor. What is the application of what is the application? कहाँ पे इस्तेमाल हो सकता है? कहाँ पे इस्तेमाल हो सकता है? कहीं ना कहीं तो इस्तेमाल हो सकता है. कहाँ पे इस्तेमाल होगा? Any idea?
Sir, toll
Or not?
plaza.
टोल प्लाजा
Parking
में
system.
यूज होता है.
Very good. Parking system. Very good. And toll plaza. It can be used in the toll plaza. It means it can be used in the parking system. It can be used to how many? Very good. How many cars to toll? And whenever a car passes, it creates an event, and that events is recorded in a counter. अब समझ आ गई या नहीं समझ आई? ठीक है. अच्छा, अब यहाँ पे क्या होगा कि we can also use the counter. If you look at the counter in a two mode, it can also be used to count the clock pulses, that is the clock pulses in say, and it can also use to count in as a events. So this count in, if you look at this copy, so it can be used. Okay, so if you look at this, if you are in this mode clock, so it is acting as a timer, and it will count in, so this is an event, and the mode is determined. So it means that if the mode is 0, what is it determined? Because you are using a 2-into-1 multiplexer. It's a select lines. Select lines can have a 0 value or a 1 value. So if it is 0, it is counting the clock pulses, and if it is 1, it is selecting an event. Okay, so when select lines is 0, so this is output. So when cell is equal to 0, output of the multiplexer will be a clock. When cell is equal to 1, what will be the output of a multiplexer? बताइए बेटा. जी बताइए बेटा. Output will be
Event.
Event.
yes. So the clock out, or it can be determined on the select line. So if select line is 0, so its output is a clock. So are we using it as a timer or a counter? Timer. And if select line is 1, so what does it imply? We are selecting this as a counter. It can be, so the counter can be used, can also be used, this counter can be used. And what is the top signal indicates? The top signal, this top. Top will be 1 when the counter reaches what? बताए बेटा ना.
Maximum.
Reaches
Maximum.
maximum value. ठीक है? When the counter reaches a maximum value. Okay. Now We also have an interval time. An interval timer. An interval timer indicates when the desired interval has passed, and we set the terminal count to the desired interval. The desired interval. Okay, so the desired time interval. So it indicates that when the desired जी what's an interval time जी बता सकते हैं या नहीं बता सकते हैं ये बताएं indicate with the desired interval pass. We set the terminal count to desired interval. Can anybody explain this? Anybody can explain this? बेटा बताएं ना आप why you are not contributing? Anybody?
सर एक दफा रिपीट कर दें.
देखिए इंग्लिश आराम से इंग्लिश लिखी है यहाँ पे indicates when desired interval has passed. Interval time indicates when desired time interval has passed, and we set the terminal count to the desired interval. Now let's assume. Now let's assume if we say if we want if we want a of if we want a delay of 500 microsecond, if we want a delay of a microsecond, and the count period, the clock period is 1 microsecond, and the clock period is 1 microsecond, and we have a 3-bit counter. So we want a delay of 500 microsecond. How we can do this? How we can do this? बताएं बेटा.
सर हम मैक्सिमम काउंट ही 16 बिट से मतलब उतना करवाएंगे जो कि डिले 500 में.
इसमें से ये होगा कि we have 16-bit counter. We have 16-bit counter. So 16-bit counter. So the maximum value. So the maximum value of the counter. What is the maximum value of the
65
65,535 multiplied by 1 microsecond. What is the maximum delay? But we want only a delay of 500. How we can do this?
सर हम काउंटिंग कम करेंगे. 500 की काउंटिंग.
इसके लिए दो तरीके हैं. There are two methods. The first method. So I will study the first method. First. Okay. So now we want to have delay of 500 milliseconds. So if we initialize the counter with 65,535 minus 500. So what's the value? 65,000
35
035. Am I right or not?
राइट सर.
Okay, we initialize the counter with this value, and then we track the top signal. When the top signal is 1, so the top signal is 1. So it means that the delay of 500 microsecond is elapsed. अच्छा यहाँ पे assumption हमारी क्या है? Our assumption is that our clock period is 1 microsecond. Am I right or not? If we change the clock period, so actually we need to revisit the clock period. So it means that now it means that now the counter value is 65,035. We initialize this. Okay. So the next time, what will be the value of the counter? After time, what will be the value of the counter? The next value will be
36 sorry.
65,036, 65,037, and it will so far so on, and it will reach 65,005. It reaches the maximum value. So at this point, the top signal will be 1. Am I right or not? The top signal will be 1. So this is an example of an interval timer. Interval time. It models an interval of time under time. Okay, there is another method. There is also another method. We can also initialize. We also initialize the counter value with a 0. Initialize the counter value. So the second method. So there is also another method. Second method. Initialize the counter. Initialize with 0 and compare this counter with 500. Am I right or not? So actually, we initialize this counter with 0. Then it will be 1. Then it will be 2. At one point, it will reach 500. We compare this counter value with an interval counter of 500. We set this value into 500 and we compare it. When both are equal, what does it implies?
Top is 1.
So it will generate a signal. It will generate a signal. Okay, the delay is not being elapsed. समझ आई बात या नहीं बेटा? यहाँ पे समझ आ रही है या नहीं है? देखिए, that is your terminal code, and in this case the delay is generated, and now this stop signal is. So in this case, initialize the counter with 0 and compare this counter with 500, and in this case the delay will be 0. समझ आई बेटा यानी internal counter? So there are two methods. Okay, so in our next class, we will study cascaded counter and prescaler counter and so forth so on. I will also upload this lecture on YouTube, and please also see this lecture